Before connecting the power supply to the mainboard and the Raspberry Pi, you should measure the voltage to make sure that the 24 volt and the 5 volt are adjusted correctly. I can't find a new Raspberry Pi, so I borrow a Raspberry Pi 02 from the ANET A8. The Raspberry Pi 02W use a micro USB cable for power supply. You can also use an old phone charging cable instead. On the power supply end, I use a Firmware crimp for a better connection. Then connect the solid-state relays to the mainboard. In the Octopus mainboard, there are 3 power supply terminals. You need to connect the 24 volt power supply to all 3 of those terminals. You also need to connect the negative terminal of both power supply together. Since I'm using a Raspberry Pi Zero, I need to use an OTG type USB cable for connection between the Raspberry Pi and the printer mainboard. The USB cable is protruding to the side, which will interference with the skirt mounting, so I have to rearrange the power supply and the mainboard to keep the USB cable inside the machine. Now we can close the cable trunk cover. I use a cable trunk in this machine to keep the wiring nice and tidy. Now for the software part, I use a Mainsail OS installed through a Raspberry Pi imager. The Mainsail OS is a package of a clipper and a web interface in a single image file. Enable the SSH and set the login and password for the SSH connection. Also, if you're using a Wi-Fi connection, please set the SSID and the Wi-Fi password. Now insert the SD card into the Raspberry Pi and power the Raspberry Pi directly. Do not connect the power to the printer mainboard for now. I can't access the Mainsail OS.local, so I have to find an IP address of a Mainsail OS in a Wi-Fi router. Before we build the Klipper firmware, we should update the Mainsail OS to the latest version first by clicking the Update button next to each component. Now there is a warning that we should update the PIP to the latest version, so I log in using an SSH command and perform the update. Now the update has complete. Let's start building a Klipper firmware. The command line for building a Klipper firmware can be found in a Voron design documentation website. The processor model setting will depend on the MCU chip of your mainboard. I use the scp command to copy the clipper.bin file into the SD card and rename it to the firmware.bin. Then insert the SD card into the mainboard and power on the mainboard. After a few seconds, the firmware flashing should be complete. We can check the result by running the ls command in the SSH terminal, which should return a serial number of the mainboard. We will need this serial number to put in a configuration file later on. For now, our printer didn't have a printer.cfg yet, so we will have to create a new file and name it a printer.cfg. Then we will copy from the Voron printer configuration template and paste it in our printer.cfg we just created. The OBS screen capture setting in my MacBook is set incorrectly and didn't capture the entire screen, so I will show you the backup file instead. There's a required change to the setting before the printer can function. The first one is the MCU part. We need to set the MCU part using a serial we get from the ls command. My Voron build is a 350mm build size, so I will remove the hash symbol in the front of the paragraph matching my build volume. Now in the stepper driver configuration, you will have to specify your stepper driver. In my case, I'm using a TMC2209 stepper driver. Here you will have to specify the sensor type used in the extruder and the heated bed. The most common thermistor type is the generic 3950, so I will set it to a generic 3950. If you are using a Mainsail OS, add the include Mainsail OS.cfg like this. After we complete the initial testing, we will have to come back to the configuration file and change a few more settings. Click the Save and Restart button. If there is no error message, we can go back to the dashboard and start an initial printer testing. The first test is the heater and thermistor testing. First, we make sure the temperature reading is somewhat correct. Then we try set the extruder and bed temperature to 50 Celsius and check the graph to make sure the temperature can rise to the 50 Celsius. You can also measure the temperature of a heated bed with a thermometer. The next test is the stepper motor testing. This will make sure each stepper motor is wired correctly and turned in the right direction. You will have to run the test for each model in your printer. After the testing, if any of the model is turned in the wrong direction, you can add an exclamation mark in the DIR pin section of that stepper model to reverse the direction. For the initial testing, I will temporarily attach the Klicky probe into the mount manually. Then click the refresh button on the end stop panel to check the end stop status. And for the LCD screen, I use a big 3-tech mini 12864 LCD screen. This LCD screen has an RGB backlight which can be controlled by a software configuration. This LCD screen is connected to the mainboard with an EXP1 and EXP2 ribbon cable. The two cables are identical, so you should put some marking on the cable to avoid confusion. Then I tried to power on the machine and found out that not only did the LCD screen didn't work, but the entire printer didn't work at all. So I started searching online for the solution to this problem. One of the possible causes is that the reset pin on the EXP2 cable is wired incorrectly and causing the mainboard to halt in a reset state. So I tried unplugging the EXP2 cable and found out that even though the LCD screen didn't work, but the mainboard is now working. One of the proposed solutions I read from Reddit is to remove the resistor R1, which is a tiny SMD resistor on the LCD screen. Here you can see the marking for the R1 resistor pad, which we need to remove the resistor. And this is the removed R1 resistor. Then I try to power on the printer again, and this time the LCD screen is finally working. The LCD screen on a Voron 2.4 is only used for a basic movement control. Most of the control will have to be done through a Mainsail OS web interface anyway. Then I try to home the X and Y axis. In the first homing test, you should prepare to cut the power in case something goes wrong. We need to configure the Z and stop pin before we can move the Z axis in a software control. In order to find the home XY position, I first install the nozzle, then move the nozzle directly over the Z and stop pin with a software control, and note the XY position. Then I continue to install the Klicky Probe macro. Those macros are required for a Klicky Probe to function properly. To install the Klicky Probe macro, we need to copy the 4 file into the printer configuration directories. Then in the Klicky Probe.cfg, we will comment out the section that we don't need for this printer. In our printer configuration, we add the include Klicky Probe.cfg. Then we will have to find the Klicky Probe docking position, which we will use the same method as finding the home XY position by using a software control to move the Klicky Probe into the dock and note the XY position. Then we will put that dock location in the dock location X and dock location Y setting in the Klicky variable.cfg file. Then I test the attach and docking probe command to see if they function as expected. Now it's time for quad gantry leveling test. In a Voron 2.4, we have 4 independent Z-axis motor, so we have to align them to the proper level before we can start the printing. Now before our first print, we need to set the Z offset, which is the distance between the nozzle and the print bed. We will use a Z and stop calibrate command to calibrate the Z offset. Actually, you will have to install the actual print bed surface before doing a Z offset calibration. For the first few test prints, I use a masking tape as a print surface instead of the actual magnetic build surface, because during the initial printing, if we set the Z offset incorrectly or some of the sensor is not working properly, the nozzle may scratch the bed and causing damage to the build surface. Alright, that's it for today. If you like this video, please consider hit the like button, share and subscribe to this channel. Thanks for watching and see you in the next episode. Goodbye.